Okay, let us start. So today we are going to continue discussion for chapter 6. And the last class we discussed about data cleaning. So data cleaning. So, and all of this belongs to data pre-processing. Okay. Data cleaning, we discussed like missing values, duplicate values, and formatting, okay, and outliers, some strategies for data cleaning. We also discussed data wrangling. So data wrangling. And the data wrangling mostly is for data transformation, okay? So to change the data frame shape. And one of the approaches that's also in data wrangling we didn't discuss in the example is about feature scaling. So we are going to discuss the example about feature scaling today, okay, after we discuss the concept about data aggregation. And for data, so data aggregation is a third part, okay, for data pre-processing. So all of this belong to data pre-processing. And data pre-processing is also, so it's quite important for data analysis, okay? And data cleaning and data wrangling, a lot of time used for before you can do machine learning with raw data, okay? And so for data aggregation, its goal is to summarize, do some summarization for larger data sets, okay? And also can be used to identify trends, okay? And it involves, so this, we're also going to see in our example, the grouping. It involves grouping data with some shared characteristic. Okay, so among the data, they may have some shared characteristic. So we can group them. After that, we can apply some functionality to the grouped data. Okay, and here it gives some examples like you do summation, do mean, or count to perform some statistic calculation. Okay, and later on in our example, we can also see we can also apply some customized function. And to apply customized function, previously we also discussed in pandas, if you recall, like the map function. So map function, you can plug in customized function. It also take a dictionary within it, okay? And if you recall, we also discussed the apply function. So this is element-wise for map, and apply is for column-wise or row-wise. And we also learned another one is apply map. For some reason, my drawing board, for some reason, to that end, not working today. So another one is apply map. Apply map is also element-wise, and you can plug in some customized function. Okay, and today we will learn another one called transform. And for transform, normally it's you apply it after you do grouping, okay? And with data aggregation, then you can simplify complex data distribution, okay, making trends and pattern easy to identify because we can apply some customization operation. You can also do group. And then we can do some plotting to provide some visualization analysis, okay? So that's a general idea about data aggregation. And basically in previous chapter, like chapter 3, chapter 4, we already discussed the data aggregation, but we just didn't summarize them together. Okay, so today we are going to see more like a group of the different data aggregation techniques together, how we do that. And for data aggregation, you can apply some functions. So majority of the function we already learned in previous chapter. If you recall, like for data frame, this describe function. The describe function we already learned, okay? And normally to provide some overview for the of different descriptive statistic for those numeric, be careful, okay, it's only for numeric columns, okay, like over here it says the numeric columns for the data frame. And we cover this in chapter 3, okay? So that's describe. If you recall, it'll provide like a minimum, maximum, and 25% quantile, 50%, 75, like those, if you recall. Okay. The second function is called value counts. Okay. So for this one, it give you the counts for each category for categorical data. And if you recall, last class when we discuss data cleaning and data wrangling, we discuss different strategy to handle categorical data and also how to convert categorical data to numeric. And we discuss for categorical data, you have nominal data and ordinal. Okay, so you can apply different strategy for nominal and ordinal. Okay. So we cover that. And so to count for different category, then you can use value counts, okay? And the next box lists the function normally related with statistic. And like mean, media, standard deviation, minimum, maxima, and variance calculation, okay? And for the next one is about the group by operations. So for the group by, we already learned the group by function in chapter 4, okay? And it can group data by categorical column and then do some customized statistic for each group, okay? So that's group by. And group by function is a very, very useful function when you do data analysis. Okay, so keep this in mind. And aggregate, so this ag function, so it can apply a function or set of function to each group. Okay, so that's what it does. And the transform, okay. So transform is after a function to each group. So you first apply the group by, okay. And then it says it's create a new column for each applied function, okay. So we are going to see them in our example. And the next one is about multi-index, multi-level data frame, okay, hierarchies for multi-level. Previously, we already saw some examples, okay, about multi-level and multi-index hierarchical, okay, data frame. And so here give us some summarization. If you recall, like set index, okay, reset index, and also how do we build a multi-index? And we can also use that from tuples. If you recall, we cover them in our examples, okay. So those can provide hierarchical indexing, okay? And if you recall, we also learned the pivot table and a crosstab, okay? So both of them discussed in chapter 4. They provide a pivot table, okay? And we also discussed stack, unstack. So this is a pair, okay? So they are used, if you recall, for and melt because they can reshape data. And the reshape basically is kind of you transform the data. So it belongs to also data wrangling, okay? Okay, so that's a general idea about data aggregation. And next, let's take a look at the example, okay? Mm, think this. Mm, Oh, I got to, is this the correct one? No, I'm sorry, that's the wrong one. That's the wrong one. Need to find this one. Okay. So the first example is regarding feature scaling, okay? That belongs to data wrangling, okay? And last class, we didn't have time to cover this, okay? So today, let's first start with feature scaling, okay? So over here, we use the example. And you can get the data from this website. And this is a very classic. So this basically is it's a data set repository for machine learning. Okay, it's a very classic website. So covers different kinds of data sets for different kinds of machine learning approaches, okay, methods. And sometimes this website may not be accessible. So if you want to do some more practice for some data, you can also download it and save it and save it to local. And so if you want to access from the website, then you just provide the link, okay? And if you want to access through local, you just provide the file name. And after that, we get the data frames, take a glimpse of the data frame, so you can call the header function, okay? So if we take a look, you will see this is the first column. So here is the index. Okay, index just using the default one. So here's the first column, and looks like second column is text, and the third column to the 32nd column of them are the numbers. And we can see for this data set, there are a lot of columns. Okay. And because for this column, it's text, is it? And if you recall, when we want to do data analysis or like do machine learning, you need to convert them to numbers. And last class, we discussed the different strategies to do the number conversion, okay, to do text conversion. And if you recall, one of the approach we discussed is called label encoder. Okay, for label encoder, this is from the classic machine learning Python package, scikit-learn. Okay, and it has a module pre-processing, and within it you can call. You need to import this label encoder. Okay, label. So you import this class, then we can go ahead to use it, okay? So first, let's take a look And because uh, the complete example for this data set is to do machine learning, but we are just going to cover the data pre-processing part for feature scaling. Okay. So over here, that's why over here, because for machine learning, normally for machine learning, you split the original data into two parts. Okay. The feature parts. So features, so normally you identify them as X, and the targets, so normally you identify it as Y, okay? And you select the columns serve as features and as targets, okay? Or targets, sometimes you also call it outputs. So let's see what column we select as feature and what column we select as um, targets. Okay. So for target, you see it's the second column. Okay. And for the features, we start from the third column. So let's go back. So second column is text. Okay. And starting from the third column to the 32nd column, they are all numbers. So looks like the feature, so X, will be all about numbers. And the targets or outputs are texts. Okay. And then one more thing, let's take a look is about the features, those X, okay? Like if you see some numbers, those are kind of in the range of 2 digits. So this is 2 digit, but this we have 3 digit. And over here, you even have 4 digit numbers, is it? But for this column, it's like a decimal. So less than 1, okay? So 0 point something number, and this is 0 point something, and this one also, okay? So even from this, we have, because over here, those columns didn't show, okay? But just from this, you can kind of see for all of the features, so those are X values. Okay, the features, they are not in the same scale. In the same scale. Okay, and when data are not in the same scale, for data analysis, especially for machine learning, because data analysis, sometimes you need to use a machine learning approach, okay? So then it will, for some, not all, okay, but for some machine learning, so for some machine learning models, for some reason, why not working anymore. For some machine learning models, they need data sets, need data in the same scale, okay? Same scale, okay? So how do we bring the data in the same scale? So that's what we call feature scaling. Feature scaling, because here we clearly see the data not distributed in the same scale. Okay, so how do we do that? And also over here, we have, so this is for Y. Okay, this is for Y, for targets, and they are text. Okay, so we first need to convert all of the text to numbers. And to do that, we can use the label encoder, okay? And over here, you get the data frame, and you do the .log to select the data and convert it. And over here, we just care about the value part, so you call the data values, okay? And to do label encoder, so to convert text to number, is it? And of course, here it's different categories, okay? And it will automatically take care of that. So you first need to create the label encoder object. Once you create the object, then you can call its fit transform function, and you plug in whatever the column that you want to do the transformation, okay? And after that, let's see. So the label encoder, so it identifies there are only two kind of text, B and M, okay? And also after that, the targets, let's see. Then you see why they are all converted to number, either 0 or 1, yeah. So label encoder can automatically take care of, okay, convert the different category data to number. So that's one. Okay, and next we discuss feature scaling, okay. So regarding feature scaling, so the first method, we use standard scaler. And this standard scaler also from scikit-learn, okay. The machine learning packages, pre-processing sub-package. And you first need to create that object, okay? After you create that object, then you just call fit transform and plug in all of the features, and then it will be converted, okay? So this X scale is converted data. If you take a look, you will see the converted data, basically, if you do the close examination, it's kind of, you will see most data, so most of the data will fall within -3 to +3. Okay, and the standard scaler basically is kind of the Gaussian normalization. So it will transform that to have the mean of 0 and the standard deviation of 1, okay? But majority of the data, you will see it will fall within this range. Why it will fall within this range? Also, this is assumed that original data has some kind of closed Gaussian distribution, okay? It's because for normal distribution, about 99.7% of the data that will fall within this range, okay, of the standard deviation of the mean. So that's why we pick this range, okay. And okay, so it will transfer, but not 100%, okay, will be within that range. So we can do further examination. So, okay, we specify that range, and then we can check. So here you do comparison, okay. You do a comparison with that range to see if it's false, so greater and equal than the -3 and less or equal than +3, okay? And this will return you either true or false, okay, regarding this range. So once you have that, that's why you can call using NumPy's sum function to find totally how many numbers will fall within that range. And with the original data, totally how many we have, you can just call the size, okay? And then we can find the percentage, is it? And of course, the total number should be greater than 0 because you do division, okay? So then you can find the percentage of the sample that fall within -3 to +3, okay, and the total sample. So here it gives us the percentage and total number. And you can see the percentage is not 100%. So there are some data sample that can be considered as outliers, okay. So this is the first approach that you can do feature scaling. Okay, we call it a standard scalar. Okay. The second one is you can also do minimax scalar. So for minimax scalar, and the data normally, if the data set, like in our case, has negative value, then mostly it will fall within the range between -1 to 1. Okay. If it's all positive, then it will be in the range of 0 to 1. Okay. And but like over here says, not all transform, just as the standard scalar, not all of them will fall within this range, okay, because there may be outliers, transformation process, and also because of precision issues, okay, the precision issue, okay, and also data may not be uniform distributed, okay. Yeah, so that's regarding minimax distribution, okay. And to do that, it's also pretty straightforward. You just import this minimax scalar, okay, this class, and then you create an object of it, then you just call feature transform, and you plug in all of the features. You're going to do the transformation, do the scaling, okay. Now that you can take a quick look, okay. And we can do some further analysis to see how many will fall within that range and the percentage fall within that range. And if you take a look, you can see fall within this range is larger, is at 99.9%. Okay. And generally speaking, normally when you do machine learning, a lot of times, most of the times, we do standard scalar. Okay. So this is about feature scaling. Okay. And the next, let's go to the example about data aggregation. And if you recall, last class, that data frame that after we did reshaping, wrangling, and it looks like this, okay? So it's a multi-index one, okay? Hierarchical index frame. So it has two level of index, date and ticker, okay? And we selected some column like adjusted closing price, and volume, okay? And the last class, we also discussed regarding that data, you can do selection, okay, for multi-index. So multi-index, previous we discussed, use this XS to cross-section. And you can also do the dot log, okay? If you do dot log, then you can use tuple. So here, for the index, you use tuple to do multi-level selection. So in tuple, then the first level here, it means everything. So everything means all of the dates will be included. For the second level, it's a ticker. Okay, we are just going to pick apples. So that's what this part. And we already covered this. Okay. So last class, let's take a quick look. So that's the result. You see all of the dates, and the ticker will only be apple. Okay. And after this, let's see, for the original, okay, not that, so that's stacked data is regarding this data. And for this data, if you take a closer look, you will find each day it has 3 ticker, okay? So the 3 ticker is different category, etc. Okay, so then over here you say, okay, because for the different ticker, I want to find more about each ticker, how it performs. Is it? I want to find like its adjusted closing price for each ticker. And okay, and then after that, so normally after you apply group by, you must apply another function. So group by itself normally doesn't stand alone. So normally is you perform some operation, okay, after you do group by. So over here, you say, okay, for each ticker, I wanted to find the mean price. Okay, so that's what you can also do, like a summation or do count or do something. Okay, so then let's take a look at the result. Yeah, did you see? Then it will just give you the mean price, is it, for each? So you will only have three tickers, closing price and mean one, okay, over all of the dates. And for the next one, similar, we are still going to do group by around the ticker, is it? And this time we do percentage change. We wanted to know this information, percentage change after you do group by. Then let's see what it looks like. Yeah. Did you see? Okay, because of percentage change, so the first day will be all null values. Okay, missing values because you compare with the previous day. So starting from second day, then it's every day. Okay, and then you can also get this as a new column. Is it? So this is going to be the new column, and after that, then you see, this is daily change becomes a new column. Okay, so we just saw how we apply group by, and after group by, you can apply some operation. Okay, and the next for that stacked data, and we do some selection. So this is just for all of the dates. Okay, and looks like we just want to find the March information, data information. So we can take a look. So it's all about March, okay? And after that, what we do is, okay, so here we do the dialog, we also do the slice. Okay, if you take another close look, you will find this is a tuple, okay? And for the tuple, it has two elements. The first one is a slice. So this time the slice provides a range. So if you do want to have a range, you can use a slice, provided the starting one and the ending one, okay? And the second level is just an apple, okay? After that, we can take a look at the result. Yeah. So it's just an apple, but you see, for the dates, it can select. Okay. And then next, for the next one, let's see. So it's still regarding that original stack data, and you try to get its index, okay? And from the index, then you call this get level value, and you provide what level you want to access. Okay, here's the date level. So date level is about of the dates, is it? And after that, you say, okay, I want to find how many unique date, because it may have some repetitive, so you want to find all the unique dates, okay? Then you output all the unique dates, so it provides this of the unique dates. And what the next section does is you also want to find some specific date is within the data, because a lot of time that's also part of your data analysis. Is it? It's kind of you also do some filtering or search. Is it? So this is also part. So you provide the specific date, and then you check if it's in that available dates. Okay, the dates we just selected, filtered. Okay, and if it is, you pick that specific dates information out, okay, and then you do some review, is it? And if not, then you just say, okay, not available. So it looks like for that specific date, you can it does so on that date it doesn't have stock transaction, so you can get the detailed information. And for the next one, if we take a look, we continue to use the dot log as it. So this is kind of similar as what we learned even in chapter 3, okay? So you just, for the index, you just select all, and for the column, you specify specific column, okay? So that's pretty straightforward. But if you take a look at the next one, the dot log, and over here it provide a tuple, okay? For the tuple, for the first part, it does that slice. So this slice will let you do the range selection, okay, kind of like slicing, is it? Yeah. And then over here for the second level, we do indexing, is it? So here you just provide the specific ticker to a list. So this is indexing, this is slicing, okay, kind of, okay. But over here, you do need to use this slice function, okay? And then you can get whatever you are looking for, okay? So that's about multi-index, some operation. Next, let's take more about aggregation. And over here, we provide a dictionary first. So for each stock ticker, you also provide its respective industry, okay, the section of industry. So we have some tech, pharmaceutical, retail, real estate, okay. Okay, after that, you get all of the tickers. So you get all of the keys. And here we also provide the date range, okay. And then we call the Yahoo Finance download, so provide the ticker and the date range, and just extract close and column or the volume, okay. And for the column, and if you recall, after we download the data, in this case, it will be multi-index. So you can provide the multi-level for the column, the name for the multi-level columns. Okay, so the first level will be metric, the second level will be ticker, as it in this case. So the data, you see, it looks like this. Okay, this is the first level is metric. The second level for the column is ticker. So that's for the column level name. Okay. Okay, we know this data set is multi-level. And the next, let's see. So over here, what we did is we do wrangling. Okay, we convert it to long format, and you also specify the level is going to be ticker. Okay, so and after that, you also reset index. So a lot of time we did this, okay, because you want the ticker originally is column, and now you want it to change it to index. So you need to call this reset index. So remember this, okay. And after that, okay, what we do is we add a new column called industry. Okay, and with that, how do we do that? Is if you recall, you have the ticker. Okay, the ticker is index, is it? And you can call the map function. And the map, this time we plug in a dictionary. So this is you plug in dictionary. And apply map, and all the other, they don't take dictionary, only map take dictionary. So keep this in mind. And then you see after that, we did add the industry column. Okay, so that's how we do this. And what the next one try to show is you can also do sorting. Okay, regarding this time, it's also multi-index data frame, etc. So you can specify the sorting key. And this sorting key is not just a single one. We have 3 sorting key. And then when we do the sort, okay, so you can provide the key you are going to sort. And also here, ascending is true. So going to arrange in ascending order. But because you're going to order in 3 by 3 different key, etc. So that's why here ascending, you said, okay, you're going to let it repeat 3 times. So this times 3, if you recall in Python, this asterisk, this times, sometimes also means repetitive. Okay, so this means you repeat it 3 times. And you also specify the axis. And after that, you see, yeah, it's rearranged. So first by date, then by ticker. Okay. So, first by date, then by industry. So first by date, then by industry, and then by ticker. So it's rearranged. That's why if you take a look, AMT, it's even after Pfizer, etc. That's why, because it's first arranged by industry. After that, it's arranged by ticker. Okay, so that's why you see this fall behind the Johnson. Okay. So if you want to do some sorting among bottom columns, you can do something like this. Okay, and what next one? Yeah, if you take another look, you will see industry is the last column because that's what we newly added. That normally this kind, when you arrange this data frame, that's not very nature. That normally you want industry ahead of ticker. That is because under each industry, okay, which company that. So how do we move this column before the ticker column? So over here, there are different approaches you can do. Because over here, it just involves a single column. You move a single column. So if you want to move a single column, you can do this. You can do pop first and then insert. Okay. So you can call insert function and specify where you want to insert. Okay, here it says, okay, I want to insert as a second column because I want to insert it before ticker. Okay. And the column is that name is industry. And you're going to pop what value you are going to, so what kind of data series you are going to use. Okay, that series you are going to get from this industry column, because if you call the pop with the column, it will get the whole column out. Okay, and you store it in this value, kind of. Okay, and then it will use this value to insert, and the name, you also give it a name. Okay, so this is approach that you can do the reordering. Okay, so you move a column. Okay, and generally speaking, this will be good for moving a single column. It's not, it will be slower when we reorder multiple columns. Okay. And because you only for single column, that's why another advantage is that it will also use less memory. Okay. But it's slower if multiple columns. Okay, so this is the first approach option. And you can also do another two option. Another two option is you define the order of the column. Okay, so that's pretty straightforward, as it in a list. And then you just put the list of the new column to the data. Okay, so this is option one. So it's kind of you just create a new data frame with some specified column in the order that you specified. Okay, so this kind of, we just call it some simple indexing, is it? And this is in pandas, it's highly optimized. Okay, so it can avoid the overhead call. Okay, because the other method you can do is called reindex. Okay, and then you provide, okay, I want to arrange it as this order. So, and this order is for column. Okay, so you specify. Okay, so compare this two. This reindex is not as efficient as the first option. Okay, so for the reindex, it has some overheads. Okay, so just give us some other option. And because over here, what we do is we call that insert. Okay, and then we also call set index to arrange the specified column as index. So basically, you see, after we do that, you have this as index, date, industry, and ticker. All these three are index now. They are not a column, okay, because you call the set index and you provide the name for the index. So for different levels, the first level is date, second level is industry, and the third level is ticker, okay. So this just shows us how do we move column, and then you can also reset the index, okay, convert a column to index. And what next one, because over here we have industry, because that's in the real world, you may also be interested, you say, okay, for different industry, what's the performance? So over here you say, okay, I want to find the closing price, what the mean is going to be, or the volume, what's going to happen, for different industry. And then you see, then in this case, it will tell you, okay, different industry, what happened, okay, the performance. And for the next one, what we do, if you take a close look at this group by, for this time for the group by, if you take a look, not like the previous, just the single column, over here, if you take a look, we have this called grouper first. After that, okay, we say, okay, we want to do industry. And so here you pass in a list. So it also allow you to do multi column or multi-index, okay, when you do group by. And for this, it's not always needed to be like the index or column name, okay? It's just some category. So over here, what you want to do is you say, okay, I also want to group by, do some monthly group by. How do I do that? So if you also want to group by months, then over here, because for our date, it's not arranged by months. Then you can borrow this grouper function. Okay, with this grouper function, you specify the index, and you say, okay, for the frequency, I want to do monthly. Then it will create a group category kind of here. Okay, a group category. It's monthly. Okay, monthly category for you. Okay. So then you say, okay, this group by will first group by month and then by industry, and then I find the mean value. Okay. So let's see if it does do that. Yeah, if you take a look, it does do that. It does monthly. So January, February, and then by the industry. Okay. So that's what this part does. And then what next to try to show, okay, we just do industry for the closing price. And after that, you want to apply some customized operation. So in this case, we want to do some Gaussian distribution analysis, maybe. Okay, it's also called Z-score, and within the industry. So then you can, like previously we explained, for the customized function, you can call map, you can do apply, you can also call apply map. But generally speaking, if you do group by, normally after group by, you can call transform. Okay, so it's more aligned with the group by function to provide some customized operation. So this customized operation, we use lambda expression to do that. So it's basically a normal distribution. Okay, and you can see, yeah, so it does provide us, and we also store it in a new column. Okay, yeah, so this also shows it's quite useful. Okay, so that's about the customized operation that you can apply after group by. Okay, and for the aggregation pivot table cross tab, so here it shows the cross tab, and for this cross tab, and you select okay the index. The index we want it to be industry, okay, and for the column we want it to be ticker, okay. So you want to find like the frequency, okay, for each industry and for each ticker, etc. You want to find some industry, or not in you want to find the frequency, okay. Then you can do the cross tab and specify the index and the column. So then it will show us, the related frequency distribution, etc. Okay, so that's all the discussion about the example for data aggregation. Okay, so basically we covered all three parts. Okay, data cleaning, data wrangling, and the data aggregation. So all of this are about data preparation. So we finished discussing about chapter 3.